We are on Analyze It Part 2, Box and Whisker Plots. I am so excited you're here, as you can tell by my bit emoji. We are going to go through the review and hopefully answer any questions that you're still struggling with. If you still are struggling with something at the end of this, please go to tutorials. We will be more than happy to help you. Your test is on Tuesday this week. We are going to start with a quick review over box and whisker plots. So remember, we have the lower extreme, which is also known as the minimum. This is the smallest number in your data set. And then we have our upper extreme, which is also known as the maximum, which is the largest number in your data set. The median is the middle number in your data set. Remember, they have to be ordered from least to greatest. The lower quartile is the lower median. When you split your data in half, this is the middle number in your lower half of your data, and your upper quartile is the upper median once you split your data in half. Okay, remember, especially if you're in my class, I tell you the first thing I do when I see a box and whisker plot is I write down, okay, this is the whiskers 25%, this box is 25%, this box is 25%, and this box is 25%, because it is broken into 4 sections, so each section is worth 25%. Your inner quartile range is from your lower quartile to your upper quartile, and it's worth 50%. So remember, your IQR is your inner quartile. Now let's take a look at section 1, the 5-number summary. When you start this problem, the first thing you should look at is, are my numbers in order from least to greatest? These are not, they are mixed up. So we need to number these from least to greatest. So the smallest number is 76. Then we have 77. And then we have a 79. An 80. 82. 88. 90. 92. And 95. Okay, and I always double check by counting. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So we're good. So the median is the number in the middle. So we have 9 numbers, so the middle number should be a 5. 5, so this number, so I have 4 over here and 4 over here, so that is true. 82 is my median, and it's right in the middle. Q1, so Q1 is my lower quartile. So Q1 is going to be the median of this middle section, which would be a 78. And then our Q3 is going to be the median of the top section, which will fall right there, which would be a 91. I'm doing these in my head, or I know that between 90 and 92 is 91. But remember, if you're not sure, just add them together. So 90 plus 92 and divide that by 2. Which that would give me 182, and if I divide that by 2, that's where that 91 is coming from. And the range is the distance from the biggest number to the smallest, so 95 minus 76, that will give me a 19. Okay, and then the IQR is a little different. It is the distance from the Q1 all the way to Q3. So this time you're going to do 91 minus 78, which will give us a 13. This is the second set of the 5-number summary. So the first thing we have to do is order them, because we can tell really quickly these are not in order from least to greatest. So we're going to start with the lowest number, which is a 9. Then we have 10, 11, 15, 17, 21, 25, and 29. So I'm going to go back and double count to make sure I have all my numbers. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So I know that I have 8 numbers, so that tells me I'm going to have 2 numbers in the middle that I'm going to have to add together and divide to figure out the median. So if I have 8, so 1, 2, 3, 4 here, 1, 2, 3, 4 there. So it's going to be between 15 and 17. This is one of those, again, I can tell it's 16. But once again, if you don't know what that median is, just add those two numbers together and divide by 2. Because if you do this and you add those two together, you're going to get 32. Divide those by 2. That's where the 16 is coming from. Okay, Q1 is my lower median. Remember, this 15 does not go away. It's part of there. So it's going to be in between the 10 and 11. So it's going to be 10 and a half. And then on the upper side, it's going to be between 21 and 25. That would be 23 would be right in the middle. Okay, and then our range is our greatest number minus our smallest, which will give us 20, but our inner quartile is Q3, which was 23, minus Q1, which is 10 and a half, which will give us a 12 and a half. In section 2, we're identifying the parts of a box and whisker plot. So in this box and whisker plot, the minimum is going to be right here, which is a 173. Our maximum is the higher point, which is 295. Quartile 1 is 181. And quartile 3 is 257. And the median is going to be 239. So what about the mean? If I asked you for the mean, what would you tell me? Well, in this data, you can't find the mean. So there's not enough information to find the mean in this problem. Okay, now we're in section 3. We're going to create a box whisker plot. So once again, we have to do our 5-number summary, and we have to put these in order from least to greatest. So I see that my smallest number is 5, and then I have an 8. I like to mark these out as I go. And then I have 9, and then we have a 12, and then we have 13, and we write both 13s. If there are 2 of them, write both of them. And then we have 18, a 19, and a 19. So the first thing I like to do is go ahead and plot my min and my max. So my min is 5. My max is 19. So I'm going to put a dot over 5 and a point over 19. And then the next thing I like to find is the median. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. I have an odd set, so it's going to be the number in the middle. So here's 4 on this side, here's 4 on that side. So 13 is my median. And I recommend on your test as well, writing this stuff out in case you make a silly mistake on your graph. We can at least see what number you came up with, and we can give more credit if how much we know that you know. And then our quartile 1 is going to be between 8 and 9, which will be 8.5. So I'm going to go to 8.5. It's going to be right in between 8 and 9 right there. I'm going to go ahead and connect this. So this was my Q1, and then if I go on this side, this would be 18.5, which would be my Q3, which will be, so 16, 17, 18.5. Oh my goodness, that's really close. This is a tiny whisker on the right side there. Okay, we are on to the second box and whisker plot. That you have to do in the review. If you hear any whining, that is my dog. He's sitting on my lap trying to get my attention. But my goal is to get this done. And then I will take him on a walk. So we have 40, 41, 42. Please do not forget to put these in order. If you do not put these in order, your box and whisker plot will be completely wrong. Okay. So I have them in order now. Always double check, make sure you have them all. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Good, got them. So my min is here. So that is 40. I'm going to go ahead and put a point. My max is 67. I'm going to come over here, put a point. Okay, so my median's going to be in the middle, so we have those. We have those. Okay, so our median's going to be between there. So we might not know exactly what's between 45 and 57. So what I'm going to do is do 45 plus 57, which will give me 102. But then I'm going to divide that by 2 to see what's exactly in the middle, and I get a 51. So 51 is my actual median. So I'm going to draw a line for that. I'm trying to color code to help. And then my lower Q1 is going to be 41.5 because it's the numbers. This is my Q1. So 41 and a half is going to be kind of in the middle there. And then we have our upper quartile, which is going to fall right in between 63 and 66. So that's actually, if you add those two together, you're going to get 129. Divide that by 2, you're going to get 64.5. So this would be my Q3. So that's going to be right about there. So then we're going to make our box. Like this, and our whiskers. Okay, we are now in section 4, analyzing the box and whisker plots. I will say in this section I had a few typos, so we're going to fix them as we go. So the first question says, which city has the greater age median? So remember the median's in the middle of the box. So those are our medians. We can clearly see Miami has a greater age median. Next, it says about what percent, it should just say, of Miami is over 44 years. So if I go to Miami, and remember, let's put those percents on, like I said. Always do that first. So you just remember to do that. Okay, so I go to 44. There are 2 boxes, so that would be 50%. Next, it says, what conclusions can you make about the 2 cities? Well, you can say that the majority of Orlando is younger than 43, and Miami has 50% that are older than 44 and 50% that are younger than 44. I'm not going to write all that down, so hopefully you have something similar. You could also say that 50% of Orlando is younger than 29 years age. Anything about the graph, but remember to use your vocabulary words like median, quartiles. You can use percents when you're describing a box and whisker plot. Okay, now we are looking at which city has a greater interquartile range. Remember we talked about interquartile range is from Q1 to Q3. So for Miami, I would do 64 minus 23, which will give me 41. And Orlando would be 43 minus 15, which will give me 28. So we can clearly see Miami has a greater spread in their 50% of their data. What percent of Orlando is younger than 29 years? So once again, 25%, 25%, 25%, 25%. So 29 and down is going to be 50%. What type of distribution does Orlando represent? This one is skewed right because of our whisker. If you look at this whisker is significantly longer. 108 is going to be an outlier in this problem. Also remember, the direction that it's skewed tells you how the mean affects the median. So in this problem, that the mean will be greater than the actual median because of this outlier on this one. Okay, which statement is true about the double box and whisker plot? Half of the test scores in your class are between 85 and 100. So if I look where 85 is, this is your class to 100. There are 3 sections there. So that's not half. 25% of the test scores in your friend's class are 80 or above. So here's 80. Nope, there's 2, so that's 50%, so it can't be that one. The medians are the same for both class. Well, here's the median for our class, and this is the median for the friend's class, so nope. So the test scores in your friend's class are more spread than the test in your class. Well, if you notice that, one, their interquartile range is more spread, but also the range is more spread. So D is the correct answer. Cell phones. In this one, what is the range of the upper 75% of each brand? So upper 75% is from here to here. So brand A would be 7 minus 3.5, which would be 3.5. And then brand B would be, I would say, from 3 25/100 right here to 6. So 6 minus 3 25/100 would be 2 75/100. And then B, which battery will last longer? I would say brand A, because if you notice, 50% right here of brand A is greater than 75% of brand B. So I would pick brand A as having a longer battery. Okay, a movie theater recorded the number of tickets sold daily for a popular movie during the month of June. The box and whisker plot represents data of tickets sold in hundreds. Okay, which conclusion can be used? The second quartile is 600, so second quartile would be 400, so nope. The mean of the attendance is 400. Well, I cannot find the mean in a box and whisker plot, so that cannot be the answer. The range of the attendance is 300 to 600. 300 to 600 is the interquartile range, not the range. And then 25% of the data is between 3 and 400, and that is true because one section right here, that's 25%. Okay, we are on to the last section, section 5, the distribution of data. So all I wanted you to do is create your own and label each type. So let's start with a skewed left. So a skewed left means that most of my data is on the right. So we're going to say that we have this. Okay, so this is skewed left because 75% of my data is on the right. So this outlier right here is going to cause my data to skew to the left. And that means my mean is going to be less than my median. Okay, now let's do a skew right. Okay, so this outlier is going to cause my data to skew right because most of my data is on the left. So it's skewing to the right, which means my mean is going to be greater than my median. And then our last one would be a symmetrical distribution, which means my mean is going to be equivalent, close. It might not be exact. It may be close. So let's do the squigglies instead of the actual equal sign because it'll be close. And sometimes it might be equal, but most of the time it's just going to be close. High five, you've made it to the end. Good job studying for your test. I know you're going to do great tomorrow. If you have any questions, please be prepared to ask them in class on Monday.